All right, in this lesson, our goal is going to be to create a reusable coin object to add to our game level. The coin is going to always spin, and it's going to include a mechanism by which if the character in your game touches the coin will disappear from the game level. In this lesson, we're going to be implementing pretty much all of the 8 points that we covered in the last 2 lessons, where we covered all of the basic fundamentals of programming that you need to know to get started in creating a game in the Godot game engine. So you're going to see all of these 8 points pop up throughout this quick lesson. Let's go ahead and jump in. First off, to create a simple coin object that I want to be able to reuse in any level of my game, I'm going to go up to the top bar where I can press the little plus button up here to create a new empty scene, because after all, in Godot, whenever you make a reusable object, you want to create it in its own scene. And we're going to start off this coin object not using a physics type of node, like if I go ahead up to my scene dock where I add my nodes, if I press the plus button, we've been adding objects into our game that are solid physical objects that can bump into other things and interact with gravity. That's not quite what we want our coin to be. We want a coin object not to bump into other objects and be able to be pushed or push other objects. Instead, a coin is going to act more like a ghost, more like a zone that can detect if other objects enter it, but won't actually bump into other things. To add an object like this, we're going to go into the branch of our main node tree called Node 3D, and then we're going to go into the section called Collision Object, which is, yes, where we find all of those physics types of objects. Instead, though, we're going to add what's called an Area 3D. An area, well, is a region of 3D space that detects other collision objects entering or exiting it. That's exactly as it would be described. I'm going to go ahead and make my first node in this scene, the root node, an Area 3D. Of course, you can search for area and find it yourself that way as well. I'll go ahead and double click on it to add it as the root node of this scene. I'm going to rename it as coin and press enter. There we go. And of course, when we're making objects that we want to add to our game and be able to see those objects and have them be able to interact with other elements in our game, well, we have a warning here. That's one clue. It tells us that this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 3D or collision polygon 3D as a child to define its shape. We've seen this warning before. When we make an object that needs to interact with other objects in the game, even if it's just an area, it still needs a collision shape and it needs to look like something. So we're going to add a mesh instance into this scene as well. So I'm going to select the root node first. I'll click right on it, and then I'll press the plus to add a mesh instance 3D. You can search for it if you don't have it in your recents, but you probably should. So I will double click to add it as a child of the root node of this scene. I will go ahead and select that mesh instance 3D and go over to the inspector where I can give my mesh a primitive. I'm going to use a cylinder mesh by selecting it right there. Now, this cylinder mesh is not the right size and shape for a coin. So I'm going to click on the little resource here that we've just added, and that should expand out. If I click on the little thumbnail, the section with the light blue outline that tells me all of the properties of this simple mesh resource. I'm going to make the top radius and the bottom radius 0.3, and then I'll click down here and press 0.3, and I can press tab to jump to the next one, and I'm going to say 0.15 as the height of my coin. We can change this later, of course, by going back into the scene, but for now, that looks kind of like the shape and size of a coin that I'm going to want. Of course, it could be way too big or way too small. We can go back and adjust that later if we need to. However, I need to rotate it, so I'm going to grab the blue little gizmo here for rotating, and if I hold Control as I'm dragging that around, it will snap to 15-degree increments. And you can see right down there as I'm rotating with the Control key how it's rotating and how many degrees I've rotated. So I want it to say -90 right after I rotate it for the first time. So you'll see I'll hold Control. Oh, pardon me, it's 90 degrees, not -90, but there we go. Okay, I need to add a collision shape into this scene as a child of my root node. That's what this warning is about. So I'll select the root node again and press plus. I'm going to add that collision shape 3D. Of course, you can search for it in the main node tree available to you, but here it is. I'll double click on it to add it as a child of the root node. It has a warning because this collision shape 3D needs a shape. I'm going to add a cylinder shape 3D, although if you wanted to save a little bit of calculation and resources in your game project, you could simply add a box shape and make your collision detection a little bit easier on your user's computer. I'm going to use a cylinder shape though, just to show you what that looks like. This cylinder shape has two little pink handles, one for the radius and one for the height. I'm going to go ahead and undo that transformation with Control Z though, because I'm going to expand out this resources properties, and I'm going to type in height 0.15 to match the shape of the mesh, and the radius is 0.3, I think it was. Now I can go ahead and rotate the collision shape the same as before. I'll hold Control on my keyboard and I'll rotate the collision shape to match. So now I have this collision shape matching the mesh, and I have my root node called coin, which is an area 3D. I can go ahead now and press Control S because this is a scene that I need to save. It's going to name it coin.tscn, the same as the root node of this scene, but lowercase, and so I'll press save. There we go. Now, in order for this coin to be interactive, we need to add a script file onto this coin. And if we add the script file into this coin scene, anytime we make a new instance of this coin scene in our level 1 scene, every single coin will therefore get the same code, which is what we want. So before I actually add coins into my game level, I'm going to go to my coin scene. I'm going to select the root node of the coin, and I'm going to press the add script button. When I press add script, I'm not going to change anything in the script settings or the options. It's going to call the script coin.gd, which makes sense. I'll go ahead and press create. When I add a script file to the coin, you should now see a little icon for a script right next to the root node of your coin scene. And at the very top of your coin code, you should see extends area 3D, because this code file should be able to access and control the overall coin object, meaning its root node, which is an area 3D. So that should match the type of node that you've added it to. Perfect. We have these two default functions. They are the ready function and the process function. Above those two, we're going to create a new variable. In fact, it's going to be a constant. This is going to be a lot like the code for, I'll jump back to my 3D workspace for a second and back over to my level 1 code. This is going to be very much like this spinning sprite 3D that we added in the last couple of lessons. However, if I go back to my script workspace and we're working here on the coin.gd file, of course, that we just made, I'm going to make a constant. So I'll type const and a space. This is going to be a variable that keeps track of how fast my coin should rotate. And we're going to make the coin rotate not with any kind of animation, which I haven't covered how to do keyframed animation yet in this course, but don't worry, we will. This is going to be programmatically done. So we're going to rotate 60 times per second by making this variable. I'm going to call it rot for rotation in all capital letters underscore speed. Please recall that when you make a constant, typically, according to convention in GDscript, you name constants with all capital letters, and you cannot put spaces in a variable or constant names. So we're using underscore to mean a space. Okay, I'm going to make the rotation speed equal to 2. And so this is going to be an integer variable, and that's fine. Let's go ahead and write a comment right after that line to describe what its purpose is. So at the end of that line, I'm going to write a # or a hashtag, and I'm going to describe it as the number of degrees the coin rotates every frame. There we go. So now if I forget what that constant is for, perhaps in a few weeks, I can go back and I can read that comment and go, oh yeah, that's what that constant is for. It's for the number of degrees the coin rotates every frame. Perfect. Let's go down now to our process function, which runs 60 times per second ideally. And instead of this word pass, I'm going to type in some code to make our coin rotate on the y-axis 60 times per second. Do you recall from the last lessons exactly what that method call is that rotates the object on the y-axis? Well, if you don't quite recall, let's go ahead and jump back into our documentation. Recall that if I hold the control key on my keyboard and then I hover my mouse over any keyword that's part of GDscript, like area 3D or ready or process, I can hold control and click on that keyword to jump me into Godot's documentation where it'll tell me what that is for. I can read about what an area 3D is for. I can look at all of the properties, which are variables that exist in this class that I can access and use if I need to and I want to and I know how to. Of course, a class often contains methods, which are basically functions that exist inside of a class that we can use if we, again, need to or know how to or want to. In this case, I can't find a method here that lets me rotate on the y-axis this area 3D. However, if I go back up the top of this class, you can see that this class inherits other classes. So an area 3D inherits everything that's in the code of a collision object 3D. And by the way, these nodes that are inherited by area 3D, they are in the same structure or hierarchy that existed when we added the nodes in the first place when I went up to the plus button in my scene doc and I started by looking through this node tree. Well, under node 3D, under collision object, there was my area 3D. So area 3Ds inherit everything from collision objects, and collision objects inherit everything from node 3Ds, and node 3Ds inherit everything from the basic node class. So you can see that same structure right here. If I click on any of these classes which are inherited by area 3Ds, like node 3D, if I jump a couple over, you can see that with node 3Ds, they are inherited by all the types of nodes that are under that branch of node 3D when I'm adding nodes in the first place. So hopefully that makes a little bit more sense now. If I go ahead under node 3D and I scroll down to the list of methods, you can see here that method that we used a couple of lessons ago called rotate_y. If I click on that method name, you'll see it right here. It rotates the local transformation around the y-axis by an angle in radians. So if I go back to my coin script, which is right here, I can say in my process 60 times per second game loop, I can call that method called rotate_y, and I'll use my down arrow key and select it. And I can tell this object to rotate on the y-axis by giving it an angle in radians. However, our rotate speed variable is the number of degrees, which I'm more comfortable thinking in, more so degrees than radians. So I'm going to call that function right in the parentheses of my method call of rotate_y. I'm going to call deg to rad, degrees to radians. If I go ahead and press enter to complete that function call, I can now put my rote speed variable right inside of these parentheses, rote_speed, just like that. And now 60 times per second, we should have rotation. Let's go ahead and do a Control S to save. I have not yet saved my coin scene since I last updated it. I can tell that because there's a little asterisk next to the scene name. So I'll select that scene, Control S to save it. There we go. If I go back into my 3D workspace and then I go back to my level 1 scene, I'm going to add an instance of that coin into my game level. If I select the root node of my level scene and I press the link button, I can add an instance of my coin into my level 1 scene by selecting it and pressing open. I now have, if I orbit around and move the coin up and over, a coin is now in my game level. If I do a quick Control S to save and I go up and press play scene, will our coin be there and will it rotate? Yes, it will. If I move my character with the arrow keys, can I collect the coin? Will the coin disappear? No. So let's go ahead and enable that. I'm going to jump back into my coin scene and into my coins script. I can click on the little coin script icon right there. What I want to do here is say, if the character touches this object or collides with this object, I want this object to actually delete itself from the game level. How do we do that? Well, there's actually quite a quick and easy way to enable collision detection, and that is by using an if statement. In my game loop, in my process function, I can write an if statement that says if this object, the coin, detects any physics object entering it, we can basically write any code that we want to happen as a result of that event. Now, this is not going to be the way that we're going to accomplish this collecting, disappearing coin mechanism, but I'll show you it very quickly. If I hold Control and go back and click on this Area 3D to go back into my Area 3D class documentation, and I'll go and close the bottom doc on my screen, there is a method in this Area 3D class called has overlapping bodies. And if I go ahead and click on that method name, it'll jump me down in the documentation to that section of this page. This is a method that when you call it, it returns true if it finds that there's any intersecting physics bodies with this area. This method returns a true or false value, and therefore this method is called a Boolean method, which is a method that returns true or false. We can use that in our if statement very easily. If I go back to my coin script, coin.gd, and I say right under my rotate Y line of code, in fact, I'll put an extra empty line so that we're not crowding things too much. If I write the word if, all lowercase, and then I call that method, which was called has underscore overlapping underscore bodies, physics bodies, not other areas. So I'll press the down arrow key and press enter. If this area has overlapping physics bodies, what do I want to have happen? Well, I have to end this line with a colon, and I'll press enter. Please make sure that when you're typing this if statement, you are one extra tab in from the left side of your text editor. So you have to have one tab before the word if, because you're inside of your process functions block of code. If you have this, it will not work. If you have too many tabs or you typed spaces, it will not work. Okay? It needs to be one tab. Likewise, after I click at the end of this line and I press enter, I should have two tabs in because now I'm making a new block of code for the result section of this if statement. What I want to have happen if there are overlapping bodies with my coin? Well, if it's the character, I want the coin to disappear. And it turns out there's a very handy method that you can call called queue_free. Queue_free is a funny sounding method. It essentially means delete this object from the game. Essentially, when you delete an object like a coin from a game level, you are essentially freeing your game's memory, the memory that your computer is using to run your game. You are freeing that memory of this object, the coin. To queue means to line up. So basically, you're telling this coin, line up to be deleted from the computer's memory. That's what it means. And how long will it have to wait in line to be deleted from memory? Well, generally, that's 1/60th of a second, which is very fast. It's one tick, one frame refresh of your game. Okay, so if I press Control S to save and I go back to my level 1 scene, I'll make that tab the active tab before I press play scene. And now if I move my character, if I collect a coin, the coin has now disappeared. Isn't that nice? However, you generally don't want to use an if statement for very common events like an Area 3D detecting collisions. Why not? Well, if I go ahead and hold Control and click on this has overlapping bodies method call name, so if I hold Control and click on it, well, it'll jump me to, in my Area 3D documentation, the description of this method. Basically, it tells you here, for performance reasons, collisions are all processed at the same time. The list of overlapping bodies is modified once during the physics step of your game calculating everything 60 times per second, not immediately after objects are moved. Consider using signals instead. What this is basically telling you is that there might be a very slight delay between the time where the area detects that there is something colliding with it and the time that it can actually react to that event. So they recommend that you use what's called a signal instead of an if statement. So I'm going to go ahead back to my coins code. I'm going to leave this code here, but I'm going to comment it out for now. So I'm going to select those 2 lines of code and I'll press Control K on my keyboard. Control K will comment out any lines of code that you have even partially selected. So you'll see hashtags at the beginning of those 2 lines. Instead of checking if a collision is happening with an if statement, we're going to use what's called a signal. What is a signal? Well, if I go back to my 3D workspace and select this coin, which I should probably name coin 1, there we go. Actually, like with any coding that we do on our coin, we should probably be doing this inside of our coin scene instead of on just one instance of one coin in this game level. So I'm going to go back into my coin scene, which if I don't have this scene tab open, I could just click on the little scene icon next to this or any coin that I have in this game level. So if I click on the little clapboard scene icon, it'll open up the coin scene in my middle workspace. So there we go. I'm going to select the root node of this scene, which is an area 3D. And over on the right side of my screen, there is of course our inspector dock, but one dock that we haven't talked about that's right next to the inspector, it's a tab, it's called the node dock. And what this node dock has is a few different pages really. It has a page for signals, which is what we're going to use. It also has a page called groups. In our signals though, we have a list of signals which are available for this type of node that we have selected, our root node. A signal is basically a way of handling a common type of event that can happen with that kind of object. An area 3D has a list of common events, like when other areas enter this area. That's what this signal is for. If another area is colliding with this area and then exits this area, we can handle that with this signal very easily. The signal that we want to use, though, is called body entered, which is right here. If another physics body enters this area, like our character is a physics body, we want to trigger this event, this signal. A signal is not only a common event in at least our default list of signals here, but it's also a way that you can communicate to any other object in your scene or any piece of code in your scene and run a little function that you create with your own code when that event happens. Essentially, a signal is a way of running your own custom code when an event happens, and essentially a signal is a constantly running check, like an if statement in a loop, but more efficient than actually writing an if statement in a loop yourself that will act quite nicely. So I'm going to go ahead and select the root node of this coin scene, and I'm going to go up to my node tab down to body entered. I'm going to double click on body entered. It's going to make a pop-up on the screen that's going to ask me, where do I want to make a little function of code that will be executed when this event or signal happens, and the signal is therefore emitted to run this little piece of code. Where do I want to put that function that we're going to write to handle this event? Well, the default is probably okay. There is only one code file in this scene. The code file is on the root node of this scene. It's right here. It's going to put a function at the bottom of that code for us called onBodyEntered, which means when a physics body enters the area, do this function of code. I'm going to press connect. I didn't change anything here, so I'll press connect. It's going to jump me back into that script where it has made a function for us. Func on body entered, and there's no relevant code in here. It just has a pass right there. And so this function will now be executed whenever that event happens. And I can double check that because number one, there's now a little signal icon next to the root node of the coin. If I click on my root node of the coin and go back to that node dock on the right side of my screen, you can now see that under body entered, there is now a little icon with a function name right here. That means that this signal is calling a function. I can double click on it right there to jump me right to that function in the right code file. Isn't that nice? And that same little icon is right next to my function name. If all of that is true, if the icon is there next to your root node, if there is a green icon under body entered and you have that same green icon next to a function that it made, you're all good to go. What are we going to do if this coin is entered by a physics body? We're going to queue free. So I'm going to copy that and paste it right there. And if I do a Control S to save, we've now made a more efficient collision detection mechanism, more efficient than just an if statement inside of our own loop. We've used a signal. So I'll go ahead and press Control S to save. I'll select my level 1 scene. I'll press play scene. And now I can go ahead and collect this coin and it disappears. My signal works and we have a simple coin with a simple coin collecting or at least a disappearing mechanism. And that was our goal for this lesson. To finish off, I'm going to actually delete that commented out code that we added before, the if statement. It's generally not good practice to leave code that's commented out that you don't need anymore. So now that we have a better way of doing a collision detection mechanism in our code, I'll delete these lines of code as well as any extra spaces that I have. There we go. That'll be it for this lesson. Thanks again so much for watching. I'll see you in the next one. Bye-bye.